Welcome to Farmer's Technique. Today we are going to do these geometry questions, and today we have a circle, and then we have two chords inside the circle, and then we have the chords outside the circle, intersecting chords. These two intersect each other, and these two chords intersect each other as well. Yes, I'm not sure AE is a chord because I forgot about the definitions of chords, and I only remember the definitions of chords is a straight line inside the circle and which touch the circle. Yes, I can only remember it. But anyways, I'm going to call this as chords as well. Never mind. And here, to find our EF, what should we do here? First, we are going to look at PD. How can we find the value of PD here? Here is two chords, and then it is the intersecting point. So we can use our intersecting chord theorem, which is called this length times this length is equal to this length times this length. So first, we are going to use our intersecting chord theorem, which is inside the circle. These situations, which is 2 times PD is equal to 3 times 4. And here, 3 times 4 is 12, and then divided by 2 on one side, you can get PD is equal to 12 over 2, which is 6. So we can get our PD, which is equal to 6 here. And next step, here, we are going to find the value of this AE. AE, the value of AE, which is equal to 2 plus 6 plus 6, which is equal to 12 plus 2, which is 14 here. So our whole length of AE is equal to 14. Then we are going to use this here. Use this. Wait a minute. But first, we are going to find the value of CE first. To find the value of CE, you can see our PE, which is equal to our 12, 6 plus 6, which is equal to 12. And then we know our PC is equal to 4. And here, the angle CPE is equal to 90 degrees because the definitions of intersecting chords which makes this angle is 90 degrees. So here we can use our Pythagorean theorem. So here, to find our value of CE, we can use our Pythagorean theorem, which is CE square is equal to 4 square, which is CP square, plus our P square, which is 12 square. So we can get our CE is equal to 4 square plus 12 square, and then take a square root. You can get this is square root of 160. And think about perfect square here. So which is, this is gonna be 16 times 10. Which 10 is not a perfect square, so we can simplify it to 4 times square root of 10. So we can get our CE, which is equal to 4 times square root of 10. Okay, yes. So we know that CE is equal to 4 times square root of 10. Let me just label it here. We know that angle CPE is 90 degrees, so we can use our Pythagorean theorem to find our CE here. So that's no problem. Here, we are going to find the value of EF here. So what can we do? So we have a chord. Remember, this chord, to use our intersecting chord theorem, which outside the circle, you need to be sure that chord is go from point of a circle, which start from here. Yes. And the definitions of that theorem outside the circle, which is from here to here, and not from here. Remember that this course is PE and not AE. This course is AE and not PE. Remember that. So how can we use this theorem? Yes, the theorem says if we have two chords outside intersecting points, it definitions which is that formula says this length times this whole length, which is equal to this length times this entire length. So we can get this length first, you get EF, and then time this entire length, which is 4 times square root of 10. And then we know that DE is equal to 6, so we can get 6 here. And time this entire AE, which is 14, we already calculated. And then here, we are going to do 6 times 14 divided by 4, which you are going to get 21. And then divided by square root of 10 on both sides. And then we can simplify it here. Simplify to irrationalize here, so we can multiply the top and bottom by square root of 10. Therefore, you can get our result, which is EF. The result is EF is equal to 21 times square root of 10 over 10. And this is our result. And thanks for watching. And comment down below what do you think about this video. And bye. And stay tuned for the upcoming videos.